Good morning, students. So, today we are going to start with the second portion of our fifth unit, and today we are going to discuss about Boyle's law and Charles' law. Okay, so first of all, Boyle's law. Boyle's law was given by Robert Boyle. Okay, name of the scientist is Robert Boyle, and since these all gas laws, they deal with pressure, volume, and temperature. And when we talk about Boyle's law, then it deals with the pressure and volume relationship. Okay, so what is this Boyle's law? Now this Robert Boyle, he performed a large number of experiments. On the basis of his experiments, he reached to a conclusion that at constant temperature, the pressure of a fixed amount of gas varies inversely with its volume. Now see, what is the condition? The temperature should be constant. If temperature is kept constant, then pressure and volume, the relationship between the two is pressure is inversely proportional to volume when temperature is constant for a fixed volume of gas. Here N stands for amount of gas, number of moles of gas. So volume should be, amount should be same. Okay, amount should be same, temperature should be same, then pressure and volume, they are related inversely to each other. Okay, now when we remove this sign of proportionality, then a constant will come. Let us suppose the constant is K1. Okay, so we can write this equation, first equation, like this. Okay, now if I take V that side, then it becomes PV is equal to K1. And what is K1? K1 is constant of proportionality. What does it mean? It means PV is equal to constant. So what does it mean? It means that at constant temperature, product of pressure and volume of a fixed amount of gas is always constant. Okay, so this is the law. So whenever you are asked that define Boyle's law, what you will say? You will say that for a fixed amount of gas, the pressure of gas is inversely proportional to its volume at a constant temperature, and then you will write P is inversely proportional to 1 by V. P is directly proportional to 1 by V. Okay, and then you will write PV is equal to constant, and then at the end you will say product of pressure and volume will remain constant for a constant temperature and constant amount of substance. Now for mathematical purposes, for numericals, we will be using the equation P1 V1 is equal to P2 V2. Now what does it mean? It means that since we know that if temperature and amount of substance is constant, then product of pressure and volume is constant. So 1 stands for initial conditions, 2 stands for final conditions. Now suppose this is initial condition and this is final condition. Then what will I say? V1 is 1 liter and P1 is 1 atmospheric. Okay, so what is their product? P into V is 1 into 1 means 1. Okay, now if V2 volume becomes 0.5 liter, then pressure becomes 2 atmospheric. So what does it mean? It means P into V. Now here it is P2 and this is V2. So P2 into V2 is equal to again 1. So it means product of pressure and volume remains constant, but the condition is temperature should be same and amount of substance should be same. Okay, so this is the equation which we are going to use for numerical purposes. Okay, now if we plot the graph, now what we said? We said P is inversely proportional to 1 by V. Okay, now if we plot a graph between P and V, then what should happen? With the increase in V, P should decrease. So here P value is maximum, and when we are increasing value of V, then P starts falling down. Now this is the graph for this fixed temperature. So it is a curve which shows the decrease in pressure with the increase in volume. Okay. Now if we take lesser temperature, then this becomes the graph, but the graph is same. Okay. Similarly, when we plot a graph between pressure and 1 by V, then what happens? Now see, we have written P is proportional to 1 by V. Now if we are considering this whole thing, then P and 1 by V, they are directly proportional to each other. So it means if 1 by V increases, then P also increases. Okay. So in this case, we are going to get a straight line like this. Okay. Now at different temperatures, it will be different straight line. Okay. So these are the two graphs which can be drawn from the mathematical form of Boyle's law. Now let us come to second law, and second law is Charles' law. Okay. Now Charles is the name of scientist, and this is the pic of Charles. Now what he said? He said that volume and absolute temperature of a gas, they are directly related at constant mass and pressure. Directly related means that they are directly proportional to each other. Okay. So again, what should be the conditions? The amount of substance should be same, amount of gas should be same, and then pressure should be constant. Now if pressure is kept constant, amount of substance is same, then V is directly proportional to T, means volume of gas is directly proportional to the temperature. Okay. Now if we bring T this side, then it becomes V by T, and what will be left on that side? If we remove the proportionality sign, then constant comes, so there will be constant. So what we will say? V by T is equal to constant. Now again, just like in Boyle's law we did, here also we can write the equation as V1 by T1 is equal to V2 by T2. Here 1 stands for initial conditions and 2 stands for final conditions. So ratio of volume and temperature initially will be same as the ratio of volume and temperature finally. Okay. Now this is one form of Charles' law. Okay. And in case we are asked, we will be writing this only. But there is one more form of Charles' law, and that form is also important because from that particular form we develop a particular definition. Okay. So what is the law? For a fixed mass of gas at constant pressure, volume of gas increases or decreases for each 1 degree rise or fall in temperature. Now let us understand this much. What it says? It says that constant pressure should be there, mass should be fixed for a gas. Then if we increase the volume, if we what change will be there in volume? Volume will increase by 1 by 273.15 times the original volume at 0 degree Celsius. If we increase the temperature by 1 degree, and same volume of gas will decrease by 1 by 273.15 times the original volume if we decrease the temperature by 1 degree Celsius. Now let us understand one more way. Suppose V0 is the volume of gas at 0 degree Celsius and Vt is the volume of gas at T degree Celsius. Okay. Now first of all, let us write like this: 1 by 273.15 times V0. Okay. This is the portion which will either increase or decrease for every 1 degree rise or fall in temperature. Now, if I have to write volume of gas at 1 degree, then what I will write? It is volume of gas at 0 degree plus 1 by 273.15 times of V naught. Okay. And if I have to write for minus 1 degree, then what will I say? V volume at minus 1 degree is equal to volume at 0 degree minus, now here it will be replaced by minus 1 by 273.15 times V naught. Okay, so what is said here, that when we increase the temperature by 1 degree Celsius or decrease the temperature by 1 degree Celsius, then the volume of gas increases or decreases by 1 by 273.15 times the volume of gas at 0 degree Celsius. Okay, now mathematically how can we write it? Like, we can write it like this. Here, this is the volume of gas at temperature T. This is the volume of gas at 0 degree Celsius, and this is T divided by 273.15 times V naught. Okay, now here we have written T. Why we have written T? Because if we are taking T as 1, then here the value will be 1. If we are taking it 5, that suppose we have to say that what will be the volume of gas at 5 degree, then what we will write? V5. Okay, volume of gas at 5 degree Celsius is equal to V naught plus T will be replaced by 5 by 273.15 times V naught. Okay, so this way it will be written. Now if we rearrange it, then we can write it like this: Vt is equal to V naught within bracket 1 plus T by 273.15. Okay, so here what we say, on the basis of this, a new scale of temperature such that T degree Celsius on new scale is given by T is equal to 273.15 plus T, and 0 degree Celsius will be given by T naught or T0 is equal to 273.15, means it is Kelvin scale. At Kelvin scale we are talking about. Okay, so this new temperature scale is called Kelvin temperature scale or absolute temperature scale. Now one more interesting thing which you have to remember here, this we are going to discuss ahead also, but here we can see, suppose I put temperature value as minus 273.15, then what will happen? Suppose I am saying that I have to take temperature at this temperature 273.15 degrees Celsius. Okay, what will be the volume? So here Vt will be replaced by V minus 273.15 degrees Celsius is equal to V naught within bracket 1 plus, here when I will write minus 273.15, then 273.15 and 273.15 will cancel and 1 minus 1 will come. 1 minus 1 means 0. It means V at this will be equal to 0. So what does it mean? It means theoretically it means that when we attain this temperature for any gas, suppose I am having any gas, one cylinder of any gas, and I am taking that gas to this temperature minus 273.15 degrees Celsius, then volume of gas will become 0. Okay, so what is this? What do we mean by this? This is called absolute zero temperature. So can we obtain this temperature? No, this temperature cannot be obtained. This temperature can never be obtained. Okay, so one thing you have to remember, that temperature equal to minus 273.15 degrees Celsius can never be obtained. Okay, one thing is this. Second thing, you are asked what is absolute zero temperature. So what is absolute zero temperature? Absolute zero temperature is equal to T is equal to minus 273.15 degrees Celsius. This is absolute zero temperature. Okay. Now, when we are talking about absolute zero temperature, then sometime we are asked what is absolute zero temperature, define it. Then we have to define it like this: the temperature equal to minus 273.15 degrees Celsius at which volume of any gas is zero is termed as absolute zero temperature. Okay, absolute zero temperature. If we don't want to say in degrees Celsius, then we can say like this also: 0 Kelvin. Okay, temperature equal to 0 Kelvin is absolute zero temperature. So here this your unit depends, unit decides everything. So unit is Kelvin. In Kelvin scale we will say 0 Kelvin. In Celsius scale we will say minus 273.15 degree Celsius. Okay, so this is the most important definition which comes out from this form of Charles' law. Now here you can see what we said. We said V by T is equal to constant. This is what we said. Now V by T is equal to constant means volume divided by temperature. Now see, this is the volume when temperature is 200. So when I will write 0.5 divided by 200, then it will have the same value as I will find here, 1 divided by 400. Okay, so these are initial conditions and these are final conditions. Okay, so V1 by T1 is equal to V2 by T2, and here pressure was constant and amount of substance was constant. Okay, now when we plot the graph, then it will be like this. Okay, when we are plotting volume versus temperature graph, we have written like this: V is directly proportional to T. But here it should not come at 0. This point is not 0. We don't have to put it at 0. This point is temperature equal to absolute zero temperature. 0 Kelvin or minus 273.15 degrees Celsius. Because when we are saying that volume becomes 0, so volume value will be 0 at what temperature? When temperature is equal to minus 273.15 degrees Celsius. So we have to show our graph till this much only. This is the graph. Okay, and this graph should not be like that on extrapolation it touches origin. Okay, it will not touch origin where the value of volume is 0. Okay, so where it will touch, this graph is going to touch, these lines will going to touch at a temperature where the value of temperature is minus 273.15. Okay, so you can draw this temperature like this graph like this also, that this is your volume, this is your temperature, and graph will be like this. Okay, so here value is 0 and this side negative values. Okay, and this side positive values. Then when you are going to extrapolate it, then it will touch somewhere like this. Okay, somewhere like this, and this value will be absolute zero value. This value will be minus 273.15. So this way also you can draw this graph. Okay, now this is what we defined: the lowest hypothetical or imaginary temperature at which, hypothetical or imaginary words we are using because we cannot maintain this temperature. Okay, the lowest hypothetical or imaginary temperature at which gases are supposed to occupy zero volume is called absolute zero. Okay, now we have studied two laws, and from the basis, on the basis of two laws we have done two formulae. One formula is P1 V1 is equal to P2 V2, and another one is V1 by T1 is equal to V2 by T2. Okay, now when temperature is constant, then P1 V1 is equal to P2 V2. When pressure is constant, then V1 by T1 is equal to V2 by T2. Now when we are talking about these things, then it is known to us that amount is constant. Amount is noted by number of moles. Amount is also constant. Now let us see this example, that which formula is applicable for this question. Okay, now the question is, on a ship sailing in Pacific Ocean where temperature is to 23.4 degrees Celsius, this is in degrees Celsius, temperature is in degrees Celsius, a balloon is filled with 2 liter air. So volume is this much. What will be the volume of balloon? Now new volume we have to calculate, where temperature is 26.1 degrees Celsius. Okay, now see, initial conditions are that we are given volume equal to 2 liter and temperature is given 23.4 degrees Celsius. Very first thing which you have to remember is, for every numerical, temperature should be taken in Kelvin scale. If it is given in Kelvin, then take as it is. If it is not given in Kelvin, then you have to convert it into Kelvin scale. Now for conversion in Kelvin scale, we don't have to use 273.15. 0.15 part can be deleted. Just we can remember 273 is to be added. Okay. So what comes now? Initial volume, initial temperature, final temperature and final volume is to be calculated. So pressure is kept constant. Nothing is said about pressure. When nothing is said about a particular physical quantity, then that physical quantity is constant. So here pressure is constant. So it means Charles' law is applicable. Okay. Now V2 will be calculated by using this formula, and now when we will put the values, we are going to get the volume value as 2.018 liter. So 2 liter volume will increase to 2.018 liter when temperature is increased. Okay, so that time what will happen, volume will also increase. Okay, so this is the result. Now whatever we have discussed, on the basis of that you have to solve these home assignments. Okay, thank you.